So in this video, I want to explain the even ones, and that's what I want you to do for homework, to do the even ones. I mean, you can do all of them if you want. You have all the solutions provided for you on the post, but at least do the even ones. And I'm jumping right in. And let's look at the instructions. And we need to understand what the instructions mean. It says, list all the possible rational zeros. All the possible rational zeros. Now, what the heck does rational zeros mean? Rational are numbers that make sense. Irrational numbers are crazy decimals that don't make sense, right? We've already covered this at the beginning part of class, at the beginning of semester one. So when I say make a list of possible rational answers, I'm talking about those answers that are nice, like -2 or +3 or 1, or even decimals that make sense, like 1.5, or fractions like -1/2. All of those make sense. So we need to create a list of all the possible rational answers. And we're going to use the rational root theorem or rational zero theorem to make this list of possible answers. Now, I don't know if we remember, but the rational root theorem, it's written as plus or minus p over r, where I don't know why they write it p over r. I would have written this formula as plus or minus c over l, because it's really the constant at the very end, the multiples of the constant over the multiples of the leading coefficient. Okay, the multiples of the constant over the multiples of the leading coefficient. So I'm going to show you like a strategy on how to make your list, all right? And I want everybody to practice. This will be at least one question on the test this Friday. So we want to make a list of the multiples of the constant, which is 5. I mean, yeah, you could say -5, but at the end of it all, your formula or the theorem has a plus or minus in front of it. So you're going to put a plus or minus in front of each term anyway. And then you're going to put those multiples of this one over the multiples of the leading coefficient, which in this case is 1. Okay, so this is going to be really easy, creating this list of possible rational answers. And it's always easy when your leading coefficient is 1. So this is the way I recommend you set it up. I would just do, it's not really a fraction, all right? But let's just set it up like this. Let's put like a fraction bar, and let's put the multiples of the constant. So how could you get 5? Well, you could go 1 and 5, 1 times 5, right? And let's put that over the multiples of the leading coefficient, which is obviously 1, okay? Now, this is not, it's not a fraction. This is just the way that I get organized to write my list of possible rational answers, okay? So what I do is I do this setup, and then I say, okay, this one, I'm going to put it over 1. So if I do that, and then I go to the next one, 5, and I also put it over 1. And then, of course, the formula or the theorem says that there's a plus or minus, which means you have to put a plus and a minus in front of each one. So you're going to put plus minus right there, plus minus right there. You know what? The 1 is in blue at the bottom, just so we could stay color coordinated here. So when you think 1 over 1, what does that really mean? That's just 1. So you have plus or minus 1. And 5 over 1 is just 5, so plus or minus 5. So this right here is a list of your possible rational answers. Now, that's really a total of 4 possible rational answers. So the rational root theorem, if you wanted to find the answer, you use the rational root theorem to make your list. Now, this is a 4-numbered list. You have +1, you have -1, you have +5, you have -5. And in theory, from there, you're supposed to guess. Like, you could pick the number 1, and you could put the number 1 in the box, put your coefficients over here, 1, -2, -5, and you could do synthetic substitution, and hopefully you get 0 over here. And if you do get 0 over there, then you know 1 is an answer, right? But they're not asking us to find the answers. The instructions say find or write a list of your possible rational zeros, your possible rational answers, and this is it. 1, -1, 5, and -5. Those are your 4 numbers. That's your list. If you check your answers on your answer post, you'll see that that's the correct answer. It's just a list, all right? So let's move on to number 4. This one's a little more interesting, all right? And I would like everybody to follow along in your notebooks. So this one, we're gonna do again, it's not really a fraction, but this is the way I get organized. This is the way I write my list, all right? What are the multiples of the constant 3? Well, it's 1 and 3, okay? And don't forget, you're gonna put a plus or minus in front of everything. And then the multiples of your leading coefficient is 2. So how could you get 2? It's 1 times 2, okay? So again, this is not a fraction. This is messed up, right? Maybe if a different math teacher saw this on your paper, they're like, what the heck are you doing? This is the way I get organized to make my list. Now, how do I do that? Well, I'm going to pick this number first, and I'm going to take turns. I'm going to put this 1 over 1, and then I'm going to go 1 over 2. And then I'm going to do the same for 3. 3 over 1, and then 3 over 2. So again, this is not really a fraction. This is just the way I get organized. All right? So I'm going to put 1 over 1, blue 1 down there. And then I'm going to go 1 over 2. And then, now that I've done 1 over 1 and 1 over 2, now I'm going to move on to my 3. 3 over 1 and 3 over 2. So 3 over 1 and 3 over 2. And of course, there's a plus or minus in front of each answer. Now, before stating that this is my list of possible rational answers, let's simplify them. What do I mean by that? Well, we know that 1 over 1 is really just 1, and we need a plus or minus in front of it. We know that 1/2 is 1/2, put a plus or minus in front of it. 3 over 1, that's really just 3, put a plus or minus in front of it. And 3/2, or 1.5, is really 1.5, or you could write it as 1.5, or you could just leave it 3/2, and of course you have a plus or minus in front of it. Ladies and gentlemen, this is our list of possible rational answers, okay? How many possible answers do we have here? 8. We don't have 4, we have 8. Why 8? Because not only do we have 1, but we have 1, positive 1, and negative 1. Positive 1 might be an answer. Negative 1 might be an answer. Positive 1/2 might be an answer. Negative 1/2 might be an answer. And what should we do? We should plug them in with synthetic substitution to see which one gives us 0 as a remainder. That way we'll know, oh, that one's an answer. If you plug in 1 and it doesn't give you 0 as a remainder, then 1 is not an answer. Okay? If you plug in negative 1 and it does give you 0 as an answer, then you know, or as a remainder, then you know that negative 1 is a solution. Number 6. All right, guys. How am I going to set this up? Again, other math teachers would be like, what the heck are you doing here? Why are you making this giant fraction? This is the way I get organized. Hopefully you guys are seeing how I'm doing it. You guys understand it. You guys are able to do it on your own. So could somebody tell me all the multiples of 27? And I'm going to do the multiples of 27 in red. Anybody? So yeah, 1 times 27, 3 times 9, and that's about it. Those are all the multiples of 27. And now let me make a list of the multiples of the leading coefficient 9, which is just 1 times 9 and 3 times 3. Okay? Again, this is not a fraction. This is just the way I get organized. And then I start going, I pick this first number, the red one, and I use this red one on top of the 1, use the same number on top of the 3, use the same number on top of the 9. And we're going to create a long list of possible rational answers. So we have the red one. I want to do it 3 times because I'm taking turns. It's 1 over 1, 1 over 3, 1 over 9. Does that make sense? This 1 over 1, there it is. This 1 over 3, there it is. This 9 over 9. Oh no, this 1 over 9, there it is. Sorry about that. So we've dealt with the number 1. Now let's move on to the number 3. Okay? So I have 3 over 1. 3 over 3. Man, it's hard for me to stay color coordinated. And then 3 over 9. 3 over 9. Okay? So we also have, man, I guess let's keep going. So we've done the 1s, we've done the 3s. Now let's do the 9 on top of all these 3s, all these 3 blue numbers. So we have 9 over 1. We have 9 over 3. We have 9 over 9. And finally 27. Dang. 27 over 1. 27 over 3. And 27 over 9. Whew, takes a long time. All right, so let's go through each of these and write it as a list with a plus or minus in front of each one. So let's begin with this guy. That's 1 over 1. That's really just plus or minus 1. This guy right here is plus or minus 1/3. This guy right here is plus or minus 1/9. Okay, so these are all answers, possible answers so far. And then this guy right here is plus or minus the number 3. Now this guy right here is plus or minus 3 over 3, which is really plus or minus 1, but you see, I already have that. Does that make sense? I already have it, so I don't need to write it again. I mean, yeah, I don't need to write this guy again, so I'm just going to skip it because it's already there. Let me move on to 3 over 9. When I reduce 3 over 9, what does it reduce to? It reduces down to 1/3. So I don't need to write 3 over 9 again because it's already there. It's 1/3. How about this next one? 9 over 1. Yeah, plus or minus 9. How about this next one? 9 over 3. That's really a plus or minus 3, but you see, we already have it, so I'm not going to write it again. How about the next one? 9 over 9. That's plus or minus 1, but I already have it. I don't have to write it again. 27 over 1. We don't have plus or minus 27. Let's write that down. And we don't have 27 over 3, so plus or minus 27. Oh, wait, yeah, we do. 27 divided by 3 is 9. So this guy we wrote down, this one we already have because that's really a plus or minus 9. And then 27 divided by 9, that's 3, and we already have the plus or minus 3. So ladies and gentlemen, this is our long list of possible rational answers. Now, what does this mean? That we actually have 1, 2, 3, 4, 5, 6. We have a total of 12 numbers on this possible list of answers. Now, back when I was in high school, we didn't have Desmos. We didn't have graphing calculator. So we were stuck by doing this method of the rational root theorem, where we pull up all the possible answers, and then we had to test it. So I would have to go back and be like, okay, I want to plug in 1. And I plug it in 1 with synthetic substitution to see if it gives me 0 as an output, 0 as a remainder. If it doesn't, then I know 1 doesn't work. And then I would move on to my next one, plug in -1, see if it works. And then you might have to plug in a fraction, see if it works. Now, luckily for you guys, technology is here, and you guys could go to the Desmos app, okay? And you could just type in the function, and you could see where it crosses the x-axis, which actually gives you the actual answers. So that's all we're doing on this first section, writing a list of possible rational roots, and I already did all the even ones right here. If you want to practice with the odds, you could. You don't have to. But yeah, let's move on to the next section. Check these instructions out. It says, find all of the rational zeros. Find all of the rational answers. Now, what kind of answers are there? There's rational, and there's irrational, and there's also imaginary. Okay? Rational makes sense. You could see it, you understand it, like -2, like +1, like -1/2, right? Like we understand what 3.5 is, right? Those are rational answers, okay? But if you get something like square root of 7, that gives you a crazy decimal. That would be irrational, all right? Or if you end up with imaginary answers, those are not rational. So all they want are the actual answers. They don't want a list of possible answers. They want the actual answers. So back when I was in high school, I would have to create my list, and then I would have to plug in each one to check it. Luckily, you guys have Desmos. So I want everybody to go to Desmos right now and type in this function and see where it crosses. Go for it. So ladies and gentlemen, I typed it in right there. You could put y equals, you could put the f of x equals, but if you just type in the x to the third minus 2x squared plus 5x minus 4, it will give you the graph. And that tells us that x equals 1. X equals 1. Now, that is the answer. X equals 1. Now, this is a third degree function, which means that there might be two other answers that are probably irrational. They might have a square root, they might be imaginary, right? And I know that the other two answers are not nice answers, because if they were nice, they would cross at those locations, and we see that it only crosses at one location. So that's it. You're done. Just type it in, find out where it crosses the x-axis, and you're done. Why did I do number 7? So I'm supposed to be explaining the even ones. Whoops. All right, let's do number 8. So ladies and gentlemen, I have typed it in, I've zoomed in a bit, and I've hit the coordinates, which will allow me to see the exact value. X equals -2, x equals +2, x equals 3. So -2, +2, 3. X equals, and instead of saying x equals -2 and +2, I could do this, and x equals 3. And that's it. It has 3 real answers. +2, -2, and 3. I don't have to do any work. I just do Desmos, find those points of intersections, and those are rational answers. And that's what they're asking for on the instructions right here. It says find all the rational answers, the rational zeros. Let's move on to, well, I mean, I guess it's pretty self-explanatory, right? You guys should be able to get through this fairly easy. You just graph it. So I'm not going to do the rest of them. I'm going to jump to the last portion of this video, the last portion of the worksheet. Right here it doesn't say find all the rational zeros, which are nice answers. Right here it says find all of the zeros, all of the answers. So right here, let's graph number, and actually we're supposed to do the even ones. So let's graph this guy right here on Desmos. So here we are, guys. I typed it in, and I had to zoom out a bit to see all my 3 answers to this third degree equation. Now, I did click on the coordinates, and the only nice one is right here, x equals 2. I mean, we don't want to deal with this decimal. It's not crazy, but I mean, we don't want to deal with that. I'd rather deal with 2 than 7.742. So what I'm going to do is use that answer, x equals 2. It says find the answers. Okay, for sure, here's one of them, x equals 2. And the other answers are decimals. However, on your multiple choice, you're probably going to see them written in as irrational numbers, as radicals. Okay, and it's not saying just find your irrational answer. It's saying find all your answers. So we're going to use the 2, and we're going to use the coefficients 1, -10, 18, and -4. And we're going to plug it in with synthetic substitution. 1 plus nothing is 1. 2 times 1 is 2. -10 plus 2 is -8. 2 times -8 is -16. 18 minus 16 is 2. 2 times 2 is 4. And of course, no surprise, my remainder is 0, because I saw on the graph that the answer is x equals 2. If you don't get x equals 0, you better go back and do your work again, because you made a mistake. And if you made a mistake, you're not going to have the right numbers down here to create your correct depressed polynomial. All right, so this is going to be a quadratic, the constant, the x, and the x squared. So I have x squared minus 8x plus 2. Now, I already know that one of my answers is x equals 2. And I already know the decimal approximations according to my graph. That was the decimals that we saw there. But I want it written as radicals, because that's how it's going to be provided to us on the test. So I am going to use a quadratic formula to find those radicals that represent those decimal values. The a value is 1, the b value is -8, the c value is 2. Let's use a quadratic formula. And when we use a quadratic formula, let's use parentheses to plug in our values. And we're plugging in the value of -8 for b, the value of 1 for A, and the value of 2 for C. We're going to work with the discriminant first, the value inside the square root. -8 squared is 64. I'm just going to jot that down on the side. 4 times 1 times 2 is 8. So I really have 64 take away 8. And 64 take away 8 is 56. Isn't that right? 56? All right, so what we have here is +8 plus or minus the square root of 56. All divided by 2. The question is, could 56 be broken down to a perfect square number? 56 is 1 times 56, 2 times 28. So that means that I could probably break it down to 4 times something. That would be 4 times 14. Yeah. So on the side, 56 could be broken down to 4 times, you want to think perfect square numbers, right? 4 times 14, that'll give us 56. Use a calculator if you need to. That way, when you split it, you could actually do the square root of 4, which is 2, and the square root of 14 will stay. So you're going to replace this with this. So what we really have is 8 plus or minus 2 square root of 14 over 2. And if you look at that, for that answer on a multiple choice test, you will not find it. And the reason why you won't is because you could still continue to split the denominator to the 8 and to the 2 square root of 14 and then simplify, or you could just simply reduce all 3 terms. 8 divided by 2 is 4, 2 divided by 2 is 1, 2 divided by 2 is 1. So your final answer is 4 plus or minus the square root of 14. That is your answer, or your 2 other answers. Remember, this was a 3rd degree equation. You have 3 answers. You have one that's nice, rational, 2, and 2 that are irrational. They're crazy decimals. 4 plus the square root of 14, which is a crazy decimal. 4 minus the square root of 14, which is a crazy decimal. And that's how we do this, guys. Might as well do the last one here. Let's graph it. So if you type it in correctly, you will see that this even degree function that has both end behavior in quadrant 1 and quadrant 2 only touches the x-axis at -2. So my answer is x equals -2. Now, because it does not cross through it, that means that there's, this might be an answer 2 times. So I'm going to use the answer -2 to drop this down further to make it an easier polynomial to deal with. So I already know the answer is x equals -2, but I'm going to plug in -2. We have 1, we have 4, we have 5, we have 4, we have 4. We're going to go 1, -2 times 1 is -2. We have +2, we have -4, we have +1, we have -2, we have +1, no, +2, and we have -4. I know I rushed through it. We are running out of time. This becomes 0. That's great. I know I didn't make a mistake. This is our depressed polynomial. Now, again, because I said it didn't cross through it, which means that -2 probably works 2 times. So we could do it again. Plug in the -2 again with these depressed polynomial coefficients. And let's see where it takes us. It should work again. Let's see. So as I go down, combine. As I go up, multiply. As I go down, combine. As I go up, multiply. As I go down, combine. As I go up, multiply. And of course, remainder is 0 because I know that it touched, it didn't cross through, so it does have a multiplicity of 2. So the reason why I knew that -2 would work 2 times is because of the graph. Let me show you. The graph itself, when your graph crosses through, then yeah, I know the answer is -2. But when it touches, when it doesn't cross through, when it touches, then there must be a duplicity of that answer. So if it crosses through -2, okay, -2 works once, right? But if it only touches, then it's probably working twice, which it does, okay? It's just a little tip that we should use, that we should know. Now, because it worked twice, I could use now this depressed polynomial. And the depressed polynomial is x squared plus 1, all right? So they want us to find all the answers. So we already know x is -2 is an answer twice. You don't have to write your answer twice. But we do have this other binomial that we could set equal to 0 and solve, which means you'll have x squared equals -1, which means that when you square root it and square root it, you get your other 2 answers, x equals plus or minus I. So those are all the answers to number 24. X equals -2 and x equals plus or minus I. Now some of us are thinking, wait a minute, this is a 4th degree equation, I need 4 answers. Technically, it does have 4 answers. -2 written 2 times, right? You don't have to write it 2 times, but that's what we call the answer -2 with a duplicity of 2, okay? And then we have the other 2 answers, which are imaginary, plus I and a minus I. So with that said, I want to end this long video, and I hope you guys work on the rest of these questions. You don't have to just stick with the even. You could do the odds. The answers are there. And tomorrow, please ask questions on whatever you may have, because all this stuff's going to come out on the test Friday.